So this week we've been talking about estimating irrational numbers, and that was the last part we covered yesterday. So I'm going to do the last example, and I'm going really fast over this one because this is what we did in the class. Remember that this is lesson 3A. We're going to think about it, estimating irrational numbers. When we explore the idea, we ask what numbers are not rational. And we mentioned yesterday that the definition of rational numbers is really clear. Let's look at the number like square root of 2. The square root of 2, the square root of a number that is not a perfect square. So we know square root of 2 is not going to be exact solution. It's not a perfect square. Remember that the perfect squares are 2, 4, 9, 16, and so on. We have a table in page 13 of your book. So problem number 2, in this case, they're asking me, look at the number line below. The number square root of 2 is between a square root of 1 and a square root of 4. Since the square root of 1 is equals to 1 and a square root of 4 is equals to 2, that means the square root of 2 must be between what two integers? Square root of 2 in this case must be between 1 and 2. 1 and 2. Okay, how do I prove it in this case? Well, remember, I'm going to use this piece of paper. I did yesterday 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9. Okay, so in this case you have square root of 1, square root of 4, and we mentioned that this one is equals to 1, this one is equals to 2. So the square root of 2 must be between square root of 1 and a square root of 4, or 1 and 2. So 1 and 2, or square root of 1 and a square root of 4. Now, it says, draw a point on the number line, in this one, where you will locate a square root of 2. Where did you draw the point? In this case, I'm going to say, remember that square root of 2, you have a square root of 1, square root of 4, square root of 2, is closer to the square root of 1, this one. So I'm going to draw that point around here. And then you answer, I'm going to put around 1.3. Then it's asking me to calculate 1.3 squared, and that's what we did yesterday. So we did 1.3 squared is the same as 1.3 times 1.3 equals 2. So you multiply 13. I'm not writing the decimal point. 3 times 3 is 9. 3 times 1 is 3. 1 times 3 is 3. See, I just moved one decimal position. 1 times 1 is 1. And then 9, 6, 1. Now remember, you have 1.3. How many positions you have to the right? 1. How many here? 1. So you have in total 2. So we move 1, 2, 1.69. So this one is equals to 1.69. So 1.3 squared is equals to 1.69. And then we have 1.96 if we do the same steps. And then we have 2.25. And as we can see, that value has to be between 1.4 and 1.5 because it's 1.96 and 2.25. So in this case, based on your calculation, draw a point in the number line below where you will locate a square root of 2. Now, where did you draw the point? In this case, you have a square root of 1 equals 1. You have 1.5 and then a square root of 4. This one is 2. Make sure this one is 2. So is 1.4 squared, 1.96 close. So it's closer to 1.5. So I'm going to draw that one there. And then I'm going to say around 1.4. Now let's calculate 1.41 squared. Remember that one you can do exactly the same. 1.41 squared is equals to 1.41 times 1.41 equals to, now look at the decimal places, 1, 2, 1, 2. So when you multiply, you run 4 decimal places. So let's multiply. See, I'm not writing the decimal point because I'm going to run 4 to the left. 1 times 1 is 1, 1 times 4 is 4, 1 times 1 is 1. 4 times 1 is 4, 4 times 4 is 16, at 1. 4 times 1 is 4 and 1, 5. 1 times 1 is 1, 1 times 4 is 4, 1 times 1 is 1. Then 1, 8, 8, 9, 1. And we had 4 decimal places, so we run 1, 2, 3, 4. So it's 1.9881. So that's what we have. So we type it here. 1.9881. And this one is going to be 2.0164. So now, based on this calculation, square root of 2 is between which two decimals? So this one is between 1.41 and 1.42. Now look at number 8. We reflect on this one. You can continue to estimate getting closer and closer to the value of a square root of 2. For example, if you multiply 1.414 squared is equals to 1.999396, which is really close, and 1.415 squared is equals to 2.002225, also close. But you will never find a terminating decimal that multiplied by itself is equals to 2. The decimal will also never have a repeating pattern, okay? So in this case, they are telling me that you cannot make a fraction of a square root of 2. So square root of 2 cannot be expressed as a terminating or repeating decimal. So it cannot be written as a fraction. Numbers like a square root of 2 and a square root of 5 are not rational. Are not rational. You can only estimate their values. They are called irrational numbers. And it says that irrational numbers mean cannot be set as a ratio or, as I mentioned in class, as a fraction. Like A over B, where B is different than 0. So now let's try this problem. The value of a square root of the value of pi is a decimal that does not repeat and does not terminate. It is a rational or irrational number. That's the question. It is a rational or irrational number. And in this case, they are telling me that pi is a decimal that does not repeat and does not terminate. So the answer, since pi is a decimal that does not repeat or terminate, then pi is an irrational number. Okay, so pi is one of the famous irrational numbers. It doesn't, in this case, pi does not repeat. It doesn't have that repeating pattern, and pi does not terminate. It's an infinity number. So that's page 24. I'm going to move to page 25. So now let's talk about it. You can estimate the value of an irrational number like a square root of 5 and locate their value in a number line. Now, for question number 10, square root of 5 is between which two integers? Explain your reasoning. Remember that I'm going to do is using this paper, and I'm going to say, okay, they're asking me for a square root of 5. So now I'm going to look for some perfect squares. 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. So that means the square root of 4 is equals to 2. Square root of 9 equals to 3. So the square root of 5 is between these two square roots. So square root of 5 is between here. So that means the square root of 5 is between 2 and 3. Closer, then you ask the question, closer to what? Closer to 4 or closer to 9? But that's a question that we're going to answer here. So we have a square root of 5 is between which two integers? Explain your reasoning. And I'm going to say 2 and 3. And then you can write here square root of 5 is between square root of 4 and square root of 9. Then mark a point at an approximate location for a square root of 5 on the number line below. Square root of 5 is between which two decimals to the 10th place? That means 0.1, so you have a 10th place. And we are going to, this is square root of 4, 2, square root of 9, 3, and we are going 2.1, 2.2, 2.3, 2.4, 2.5. And then in this case, I'm going to mark this point are between 2.2 and 2.3, or here. I'm estimating, okay? Mark a point at an approximate location for a square root of 5. So let me erase this one. I made a mistake here. Here we go. And then we're going to calculate what is 2.2 to the second power. So we multiply. We did that multiplication. So I'm just going to write the solution so it doesn't get too long, the video. So it's 4.9284. And then I have 4.9729. And this one is 5.0176. So based on these results, square root of 5 is between which two decimals to the hundredths? To the hundredths, so 0.11 to the 100th place. And in this case, you're going to write between 2.23 and 2.24. Okay, between these two. These two. Then 13, draw a number line from 2.2 to 2.3, label tick marks at hundreds to show 2.21, 2.22, 2.23, and so on. Mark a point at the approximate location of a square root of 5 to the thousands place. So we have 3 positions to the right of the decimal point. And in this case, we're going to mark a number line. And we're going to have 2.2, then 2.21, 2.22, 2.23, 2.24, 2.25. It goes all the way to 2.3. 2.26 and continue that way until you get to 2.3. So in this case, I'm going to mark square root of 5 is between 2.23 and 2.24. We got it here. So it's around here is square root of 5. Knowing that information, we move to try another way. And I'm going to use my calculator in this case. So I have in this problem, I'm going to use this one. It says, enter a square root of 5 on a calculator and press enter. What is the result on your screen? So in this case, I'll show your screen. So I have square root of 5 here. Square root of 5. And then enter is 2.23607. So that's my approximated value, 2.23607. Okay. And then 15. If this number is equal to square root of 5, then the number squared should be equal to, and this case should be equal to 5. Because if you multiply, if you square that number and you multiply each other, it will give you 5. Then clear your calculator, then enter your result from problem 14, this one. Square the number. What is the result on your screen? So if you enter this number and you square that number, you're going to get 4.99999999998. That's how close it gets, but it's never going to get 5 because it's an irrational number. We can get close and close and close, but never to 5. Explain this result. In this case, you can say 5 is not a perfect square. So, square root of 5 has no terminating or repeating decimal equivalent. The calculator result of 2.236067 is an estimate of square root of 5. So it's an estimation, okay? Square root of 5 is not a perfect square, so we are not going to get all the way to 5. So that's page 24 and 25 explained, so you can take notes in your instruction book. In your instruction book, remember, you have a instruction, I ready instruction, and that's going to be page 24 and 25. So I hope you have a great day, and I will see you next week.